You need to do is you need to go to aplusstudents.com. You need to go to the website. Once you're on the website, you select math as your subject. This is a grade 10 maths lesson. The name of the topic for today is algebra, and we are going to review the topics, or we're going to revise the basic topics that we have done earlier. The chapter number is 1 and the lesson number is 7. Chapter number 1 and the lesson number 7, and the name of the chapter is solve or solving systems of linear equations. Okay, so what we let's go to grade 10 maths, chapter number 1 and lesson number lesson number 7. Okay, yeah, lesson number 7. So what we need to understand is what is a linear equation. Before we begin, we need to understand what is an equation. Okay, an equation is something that defines variables. We have two types of equations. The first type of equation can be a linear equation, and the second type of equation could be non-linear, right? What we are doing here is today is systems of linear equations. Okay, an example of a linear equation is a linear means straight line. A linear equation would always form a straight line, whereas a non-linear would always form a curve, right? How do we identify just by looking at the equation whether it would form a curve or it would form a straight line, right? Let's look at some examples. If I would say I have an equation 2x plus 3, an equation is a statement which is connected by variables. Okay, we have another example. Let's suppose x square plus 2x minus 1. We have another equation 1 upon x. Okay, if these were the three examples given to us, and let's see which example will form a curve and which example will form a line. So what we need to know is, in case of a straight line, the equation is always y is equals to mx plus c, right? Where m is the slope and c is the y-intercept. How do we identify? The exponent of x and y has to be 1. It cannot be any other exponent. It cannot be 2, it cannot be 3, it cannot be a negative value. Okay, so once we look at the first equation, that is y and x, right? They both have, that means the first equation forms a straight line. But over here, what we can see is this has an exponent of 2. That means this would form a curve. Okay, since the exponent is any other value than 1, it would always form a curve. What about the last one? See, we can see this is 1 and this is 1, but the exponent of x is 1 in the denominator. That means it can be further written as x to the exponent -1. And I just told you, if the exponent is any value other than 1, it would still form a curve. Okay, so now we know that just by looking at any equation, we can tell what is the form of the, if would it form a straight line, is it linear, or would it form a curve, right? Okay, let's move ahead with the questions. Let's see what they're asking us in the question. So the first question that is given to us says, we are doing linear, okay? We are doing linear. We are not doing it on the screen on a software, so some statement would be extra, which I'll remove. Okay. If this was the question given to us, and these were the two equations given to us, okay? The first equation was x minus y is equals to -4, and the other equation was y equals to 6, okay? For question number 1, they're asking us to draw these graphs, okay? Okay, before this, let's say, okay, can we, in order to draw the graph, what we need to do is, if we look at equation number 1, that was, we say this is equation number 1, and we say this is equation number 2. We need to draw these two equations on the graph. So the first equation was x minus y is equals to -4. Can we make x the subject or y the subject, right? If we make x the y the subject, can we add y on either sides? And this becomes x is equals to y minus 4. If we subtract add 4 on either sides, can we say y is equals to x plus 4, right? In order to make a straight line, whenever we want to make a line is drawn between two distinct points, right? We just need to know two values of points. So let's suppose if we take two values or maybe three values, two are more than enough. But if we would consider three values, what I prefer doing is I take one value on the negative side, one value on the positive side, right? If I take x to be -1, 0, and 1, these are the assumed values, right? You don't have to do exact. You can assume -10 and 100 also. But keeping these values near the center is preferable. So when we put x as -1 into this equation, can we say it comes out to be -1 plus 4 comes out to be 3. If we put 0 in place of x, it comes out to be 4. Agreed? And if we put 1 in place of x, it comes out to be 5. So these are the coordinates we have now. The coordinate means -1 comma 3, 0 comma 4, and 1 comma 5. Let's plot them. -1 and 3, 0, 4, 1, 5, right? If we have two or more points, can we join them together to form the line? Let's see. If I join these points together, can I say we form the line for the first equation? That was x minus y is equals to -4. Because hi dear boy, welcome. What we are trying to do is, we're trying to draw the lines on a graph. We assume some points for the values of x, and we were able to draw this line, okay? But when we look at the second equation, in the second equation, it says y is equals to 6, right? Y is equals to 6. That means irrespective of the value of x, if we take some points, at least let's suppose 3 points, okay? It's saying that when y was 6, y has to be 6 in all the assumed values. And for the values of x, we can take any values. Let's suppose -1, 0, and 1. So when we plot these points, where is -1 and 6? This is -1 and 6, 0, 6, and this value over here. So once we join the points together, can we say this line was formed? Can we say at this point the value of y was 6? Agreed? Whenever there are two equations that are being drawn on a graph paper, those two lines will be either parallel to each other. Parallel means they will never intersect, or they will intersect at a point. In this case, these lines are intersecting at this point. So once we try to look at the coordinates, what is the value of x over here? X was 2 and y was 6, right? So for this particular point, we can say the coordinate is 2 comma 6. Okay, what we can say is that the point of intersection is 2 comma 6, and we write the solution as, or we can also write the answer as, the x was 2 and y was 6. Okay, this would be your answer, or this could be your answer. Okay, you can give your answer in the form of a coordinate, or you can give the answer in form of a separate values of x and y. Okay, so what we are doing is we are trying to assume values. Okay, let's have a look at the next question. And in the next question, I will try to suppose a different set of values. Okay, let's say for the question number 2, we have this information that has been provided to us. This was the graph given to us. This is the first equation and the second equation. Okay, let's do question number 2. So I just told you that we suppose equation number 1 and equation number 2. Agreed? We need to solve them on this graph. If the first equation was given as x plus y is equals to 3, can we say y is equals to 3 minus x? If we take x to the other side, let's assume some values for x or y. The best way to assume is we take negative 1, 0, 1, or we take the x and y intercepts. What is the meaning of intercept? Like in the previous question, where this line was cutting the x-axis, this is known as x-intercept, right? At x-intercept, y is always 0. Where this line was cutting the x-axis, y-axis, this is known as y-intercept. And at this, x would be considered as 0. So we can, when we were assuming a set of numbers like this, right? What we can also assume is we can also take the intercepts. Intercepts would mean that one time you take x to be 0, you will get the point where the line is cutting the x-axis, y-axis, and once you take y to be 0, if these are the two values that we assume. So can we say y is equals to 3 minus the value of x that was 0? So the answer comes out to be 3. And if we take y to be 0, so can we say, and x still comes out to be 3. Agreed? So the two coordinates now we have are 0 comma 3, x and y, and 3 comma 0. 2 points are more than enough to draw a line. Agreed? Let's plot these points. 0 comma 3, x was 0, y was 3. In the second point it is 3 comma 0, that is this point 3 comma 0. So once we join these 2 points together, can we say the line is formed something like this? Okay, we can always extend the line. So we are saying that the first line is drawn something like this, and the equation of the first line was x plus y is equals to 3. How about the second equation? The second equation that is given to us is x is equals to 5. Okay, for x is equals to 5, we cannot assume any values for x and y because there is no y variable in this. But we know that for every point on this line, the value of x would be 5. 5 comma something and 5 comma something, right? Agreed? Because the equation said that x was 5. So value of x is fixed. The value of y is variable. You can take y to be -4, 0, and 6. Any numbers. But try to take numbers, smaller numbers, so that it's easier for you to draw it on the graph paper. So once we try to plot these points, 5 and -4, right? 5 and 0, 5 and 6. What we see over here is whenever the equation is in terms of x, it will draw a line that would be parallel to y-axis. Similarly, what we saw over here, when we had an equation of y, the line was parallel to x-axis, right? So it's vice versa. When the equation is in terms of y, it is parallel to x-axis. When the equation is in terms of x, it is parallel to y-axis. Moving back to question number 2. Once we had plotted these points, we joined these points and we formed the line. So can we say that these were the points, right? So the line we can see it would intersect at a perfect point right over here. And the coordinate for this point was 5 and -2. We always write x comma y. That means the value of x was 5 and y was -2. I'll rewrite this. 5 and -2. So we can say the solution means the points where they are intersecting is 5 and -2, or we can say x was 5 whereas y was -2, where these two lines intersected each other. So what we are doing is we are trying to solve equations by plotting them on a graph paper. Okay. Okay, let's see what else we can do. Okay, let's consider a difficult equation having more values. Okay. For the next question, it says the two equations that have been given to us are, okay, the first equation, and just a moment, please. Okay. And the equations given are these. Okay. These are a bit difficult compared to the previous question. Okay. I'll just separate the question number 2 so that we do not mix it up. Okay. So the question number 3 says, find the solution of the system of the equations, right? If this was equation number 1, this is our equation number 2. We need to draw these equations on the graph paper so that we can find the point of intersection of these lines. So if I write the first equation to be x plus 6y is equals to 6, can I subtract 6y on either sides, and can I say this is 6 minus 6y? Can I say this is my equation number 1? We can suppose a set of values for values of x and y. The convenient values are, once we take x to be 0, once we take y to be 0. So for the values of x and y, once we put x to be equals to 0, and once we take y to be equals to, we can suppose any set of values, right? So we are not bound with the, so for this 0 is equal, when we put x 0, it becomes 6 minus 6y. We can write this as 6y is equals to 6. We divide by 6 on either sides, and y comes out to be 1. So the first coordinate comes out to be 0 comma 1. So, and once we put x to be 0, so we say 6 minus 6 times y was 0, right? We put x 0, we get y. Now we put y to be 0, we find the value of x. That would be 6 times 0 is 0, and x comes out to be 6 in this case. So now what we can say is we have two coordinates with us, and the two coordinates were 0 and 1 and 6 and 0. Can we plot 0, 1 and 6, 0? 0, 1 would be this point, x was 0, y was 1, and 6, 0 would be this, because x is 6 and y is 0. So once we join them together, okay, just a moment, please. Can we say this is the line that is being formed? Okay. The first point and the second point, and the equation for this line was x plus 6y is equals to 6. This was the equation, and these were the 2 points that we found. Moving ahead to the next equation, we can say the next equation was minus half x plus 3, right? We can simplify or we can leave it at this point. Let's assume a set of values. Okay. If I, in this case, if I would assume a value that is 0 and 0, right? See, x 0 would be very convenient. Why? If we have x and y, if I take x to be 0, that means the equation was minus half multiplied by x plus 3. X was 0. That means 0 plus 3, y comes out to be 3. This is very easy for us, right? But if I take y to be 0, if I would take, let y equals to 0. So can I write 0 is equals to minus half x plus 3. Half x comes to this side. This is 3. We cross multiply. X comes out to be 6. So when we take y to be 0, x comes out to be 6. Agreed? So we can do this, right? We can assume one time we can assume x to be 0. One time we can assume y to be 0. And we found these 2 points. Can we change these 2 points into coordinates? The coordinates would be 0, 3 and 6, 0. Agreed? Let's plot these points on the graph paper. 0 is the value of x, 0, 3 and 6, 0. That means when we join these points together, they are forming a line something like this. Agreed? That means the system of equations in this case is passing through a particular point. This equation was y is equals to minus half x plus 3. Where are these two lines intersecting? The point at which these two lines are intersecting is the solution set to this question. And that would be x was 6 over here and y was 0. Or we can say x is equals to 6, y equals to 0. This is our answer. Okay. So what we do is we assume a certain set of values, any values of our choice. Preferable is -1, 0, 1 for x, or one time you take x to be 0, one time you take y to be 0. We put in both the equations, we draw the lines, and we find the answer. Any questions up till now? Do we have any question up till now? Please do ask the questions, because these are linear equations, because we can see the exponent or the power of x and y is 1. There is no other exponent, okay? Ediboy, any problem? Any question? Okay, let's move ahead to the next question. Okay, I'll go to question number 4. The question number 4 says we have this information. A graph is given to us. We need to solve these points together such that the equations given are these. These two are the equations given to us. This is our question number 4. Okay, so we can say this is our equation number 1. We can say this is our equation number 2. Agreed? Okay, moving ahead, let's take the first equation. The first equation said 0 is equals to negative x, negative 3y, negative 6. Can we add x on either sides and make x the subject? So can we say the equation becomes x is equals to minus 3y minus 6? For this equation, can we suppose a set of values for x and y? If one time I would put x to be 0, one time I put y to be 0. If these are the values for x and y, one time we take x 0, once we take y 0. When we put x 0, so we can say minus 3y minus 6. We can bring 3y to this side. We divide by 3 on either sides, and y comes out to be negative 2. Similarly, if we put y to be 0, right? That means x minus 3, any number multiplied by 0 would be 0. That means x would come out to be negative 6. So we have these two coordinates with us. The two coordinates are 0, negative 2, and negative 6 and 0. Let's plot these. Where is 0, negative 2, and negative 6 and 0? Let's join them together to form a line. Okay, can we say they're passing through this? And the equation for this line was 0 is equals to negative x minus 3y minus 6. Moving ahead to the next equation, the equation number 2. The equation number 2 says 2x is equals to 6y minus 12. Can we divide by 2 on either sides? And x becomes 3y minus 6. This is our simplified equation number 2. For equation number 2, we can again suppose certain values of x and certain values of y. We know that it's always easy to find with the intercepts. The x and the y intercept. One time we will take x to be 0, one time we take y to be 0. When we put these values into the equation, so 0, once x is considered 0, 3y minus 6, we can bring 6 to this side is equals to 3y. We divide by 3 on either sides, y comes out to be 2. When we put y to be 0, That means anything multiplied by 0 is 0 minus 6, and x comes out to be negative 6. So we can say that first coordinate, second coordinate, the first coordinate or the vertex is 0, 2, and minus 6, 0. Coordinate, vertex, and a point are exactly the same things. They are synonyms of each other. So let's plot these points. 0, 2, and minus 6, 0, right? So when we join a line over here, we would see that this line is passing through this point. By chance, it's coming the same point, but it can be anywhere, right? And we can say the equation for this line was 2x is equals to 6y minus 12. And what is the solution to the system of the equations? Where are these points intersecting? We always write the answer in the form x comma y. X was negative 6, y was 0. Or we can write x is equals to negative 6 and y equals to 0. Okay, so these are both acceptable ways of giving the answer to the final question. Okay, so let's move ahead. Let's see what we have for the next example. Okay, for the next question, it says solve the system. Very similar question, just the equations are different. Okay, just a moment, please. A moment. And I would separate this from the other question. Okay. Okay, I'm just trying to separate the working. Okay, for the next question, it says, this was question number 4. Let's see what question number 5 is asking us to do. If in question number 5, the diagram, the xy axis is given to us, and the given equations are these two, are the given equations in question number 5. What we need to do is we need to draw these equations first. This was our equation number 1. This is our equation number 2. When we write equation number 1, that is minus x minus 3y is equals to minus 9. Can we take x to the other side? And this becomes minus 3y is equals to x minus 9. Can we add 9 on either sides? We are just trying to make x the subject, one of the variables subject. So it comes out to be 9 minus 3y, equation number 1. We can suppose a set of values for x and y. We say the values of x and y, one time we would take x0, one time we would take y0. Agreed? So once we take x0, it becomes 9 minus 3y. That could be written as, we divide by 3, and y comes out to be 3. When we put y to be 0, then x would come out to be 9. So we have these two coordinates, 0, 3 and 9, 0. We have 0, 3 and 9, 0. Agreed? So if I would say, let's plot them. This is 0, 3 and 9, 0 over here. So once we join these 2 points together, we can say this line is being formed something like this. It might not be perfectly accurate because I'm drawing it on the screen, but it's very close to accurate, okay? So I can say the first equation was minus x minus 3y and minus 9. Agreed? What about the next equation? Equation number 2. Equation number 2 stated that y is equals to minus x minus 1. We do not need to simplify in this case because it's already simplified. We suppose the values of x and y. After this, I will try to do a word problem for this, okay? X and Y. One time we suppose x0, one time we take y0. So when we take x0, it becomes 0 minus 1. So y minus 0 is 0 minus 1. Agreed? And for the next one, y is taken as a 0, minus x minus 1. X comes to this side, and x becomes negative 1. Okay. So once we try to plot these points, the points are 0, 1, 0, negative 1, and negative 1 and 0. 0, negative 1, negative 1, and 0 over here. So these were the 2 points that we had. Once we try to join these points together, okay, we can join them together and we will find the answer. Okay, let's see. Where would they intersect? Okay, let's suppose they are just doing a rough sketch over here. They're intersecting over here. Okay. So what we can say is this is the point of intersection. And the equation for the other line was y is equals to minus x minus 1. And what is the point of intersection? X is negative 8, y is 6. Negative 8 comma 6, or we can say x is negative 8 and y is 6. Okay, so this is the solution to the systems of equation. Let's see what will happen in the next. Okay, I'll make a new question, question number, word problem. I'll create a word problem, question number 6. Find the solution to the system of to the equations. What happens over here is if I write the first equation to be y is equal to 2x plus 3, and if I would write the next equation to be 2x minus 1. Okay, let's see if these two equations, where would these two equations intersect each other. Okay, I will select this graph. I'll just bring the graph and I'll paste the graph. Okay, so for this question number 6, what we need to see is for the first equation, I can select any points. We knew that selecting x and y, we can take 1 and 0 also. It does not make a difference. When we put 1 as x, so 2 times 1 plus 3, y comes out to be 5. When we put x to be 0, y comes out to be 3. Agreed? Do we agree till here? That means 1 comma 5. Sorry, my mistake. 1 comma 5. This is 1, this was 5, and 0 and 3. Agreed? This would be the first equation with the points 1 and 5, 0 and 3. The second equation, that was y is equal to 2x minus 1. If we suppose certain points over here, x and y, if we take 1 and 0, same, we can still draw. If I take x to be 1, that becomes 2 minus 1, it becomes 1. If I take x to be 0, it becomes negative 1. Agreed? So once I try to plot these points 1 comma 1 and 0 minus 1, where is 1 comma 1 and 0 minus 1? Agreed? If these were the points for both of these lines, let's draw them together. If this was the first line, extended endlessly, right? The second line that we have, if we extend this line endlessly. What we can say over here is that these two lines are not intersecting each other, right? We do not have a point of intersection like we had in the previous question, right? In the previous question, we had a point of intersection over here. But in this case, we see that there is no point of intersection. That means the system of these equations, or there is no solution to these equations, right? But it took us a lot of time just to know that there is no solution to this. Right? There is an easier way just by looking at the equations. We know that the equation of a straight line is always y is equals to mx plus c when both the lines have the same gradient, right? Both the lines had the same gradient, right? This equation had a gradient that was 2, and this equation also had a gradient that was 2, right? M shows the slope. Whenever two lines have the same slope, they will never intersect. That means parallel lines have, have the same slope or gradient. Therefore, they never intersect. How can we look at this? All we need to do is we need to look at the coefficient of x. If the coefficient of x is same, they will never intersect. Let's go to the previous question. Was the coefficient of x same? Over here, the coefficient of x was -1. Over the coefficient of x was 1. It was different. First questions, coefficient of x was 1. Over here, no, -1/3, and this was 3. So when the coefficient of x is different, they will intersect. Whenever they have the same gradient or the same coefficient of x, they will never intersect. Okay, do we agree on this? Perfect. Let's try one of the questions. Okay, just a moment please. Let me re-log in, go to the algebra review 7 test. Okay, let's do one or two questions from the test and let's see what are the possible answers. Okay, the first question says, just a moment please. The question number 1 from the test. I'll show you how it can be done without drawing also. Okay, if these are the two equations that have been given to us, 3 over 2x minus plus 7 minus 12 2y. Okay, if these were the two equations given to us, they're asking us to pick one of the options for the answer. Okay, so if the two options given to us are these, this is question number 1 from the test. So which option should be correct? Can anyone tell me how it could be done? Okay, I'll give you a very easy way out so that you can practice the other question. You don't have to draw all these equations, right? What you do is you select one of these equations. Which one of these equations looks easier? I think equation 1 looks easier. Just to find which of these answers is the correct, okay? Because answers are already given to you, right? I think equation 1 is easier. I write equation 1 minus 2x 2y minus 12. This is the left hand side of the equation. This is the right hand side of the equation. Pick the first point. That was 2 and -4. That means x was 2 we put x to be 2 and we put y to be 4, negative 4, right? We put x2 and negative 4. X is 2, this is negative 4. Minus 2 into minus 2 is negative 4. Minus, this would be negative 8, negative 12. We can say minus 4 is not equal to minus 20, right? That means this is not the answer. If this is not the answer, then automatically this is the answer, which we can prove also. Left hand side, right hand side, same equation. Minus 2x is equals to 2y minus 12, and the coordinate was given as 2 comma 4. So we replace x by 2, y by 4. Sorry, x is replaced by 2 and y is replaced by 4. Minus 4, 8 minus 12, we say minus 4 is equals to minus 4. It should satisfy the equation, and this is our answer. Through the working, rather than sketching the graph, we can do it through the working. We simply select any one equation, put down the values of x and y. If the left hand side of the equation is in this case, that was not equal, right? In this case, the left hand side was not equal to that, but in this case, it was equal. So whichever is equal, that means it justifies the equation, and we find the answer. Okay, please do try the remaining questions. Okay, have some practice. If there is any problem, just go through the lesson again, go through the video so that you may be able to complete that. Okay, thank you so much.